quick review of some of the rates free response problems. Number one, you're given the number of people in line to purchase tickets. And in A, they ask you the rate at which the people waiting in line was changing. So you need to estimate L prime of 5.5, but in that it becomes clear you'd estimate it using f of 7 minus f of 4 over 7 minus 4. B, asked a lot of times, wants to know the average number of people waiting in line, which is 1 over 4 minus 0 times the integral from 0 to 4 of L of t dt, and you're going to approximate that using the trapezoidal sum. Now, the next question, what is the fewest number of times L prime of t must equal 0? And you've got to give a reason for your answer. Since this function is, it said it somewhere, is twice differentiable, therefore it's continuous. So all the theorems apply, and in particular the intermediate value theorem. So your reasoning would go L3 is greater than L1, and L3 is greater than L4, so somewhere on the interval 1 to 4 it has to take on a maximum, at least once. Similar reasoning, L4 is less than L3 and L7 is greater than L4, the minimum occurs. So again, critical with these things to understand when those theorems are going to apply. Moving on to number 2, what did I want to say here? Oh, this is a classic in-out problem where the amount of unprocessed gravel arriving, and again, that's a rate, g of t. So when they ask in C, is the amount of unprocessed gravel increasing or decreasing at t equals 5, you come down and you look at g of 5, which is the rate at which it's arriving. It's 98.141. But in most of these in-out problems, the out rate is very simple. In this case, it's 100 tons per hour or whatever. So you could say it was decreasing. And then lastly, in D, what's the maximum amount of unprocessed gravel? Well, the amount of unprocessed gravel would be 500 that was there times 0 plus this integral minus the 100, because you've got to be taking the gravel that's getting processed out. And if you're looking for a maximum or a min, you would take the derivative of that function, which just becomes 90 plus 45 cosine t squared over 18 minus 100, and move from there. Next problem, number 3. I wanted to mention B here. So here we go. dB dt is 1/5 100 minus b, where b is referring to the baby's weight. So I've said this a few times, but when you're going to calculate that second derivative, d dt of 20 minus 1/5 b is negative 1/5 b prime or dB dt. And from that you could say it's concave down for all of t, etc. So that was the critical thing there. What happened in C? Nothing. All right, number 5. No snow on Janet's driveway. It accumulates, so again, an in and an out problem. But in B, they ask, what's the rate of change of the volume of the snow? Well, there's snow accumulating, but also Janet by that time is shoveling. So the rate of change of snow would be the difference between those two. Lastly, number 8. Sorry for jumping around. Again, look at this. It's an in and an out problem. And again, pretty simple. The out, 250 for the first 3 hours, and then 2,000. So when they ask, find the time intervals in B during which the amount of water in the tank is decreasing, and give a reason for each answer, you got to look for where f of t is less than g of t, which occurs there in the beginning and also later on. And that's it. Good luck on your rates problems.